Lesson 6-5, Systems of Inequalities. A system of two or more inequalities with the same variable is a system of inequalities. We've already gone through graphing linear inequality on a coordinate plane, and those are ones where you have to determine if the line is going to be dashed or solid, and then do you shade above or below. A system of inequalities have two or more of those. The solution of a system of inequalities with two variables is a set of ordered pairs that satisfies all the inequalities. The solution is represented by the overlap or the intersection of the graphs of the inequalities. So our first example here, we're going to graph these on the coordinate plane and then find out where the overlapping shading is. So this first one here, I want to rewrite this. So to rewrite this, I have to subtract x on both sides and then divide by -2. Because I'm dividing by -2, I'm going to be flipping the symbol, so it's no longer greater than, it's less than. And -1x divided by -2 is positive 1/2 x. And then I have -6 divided by -2 is a positive 3. So I'm going to graph that one first. So I put a point at 3, and I have going up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. And since it doesn't equal, I know it's a dashed line, so I'm going to put a dashed line on this one. And then this other one, I have a point at 0, 0. And I have a slope of 3, so up 3, 1, 2, 3 over 1, up 3, 1, 2, 3 over 1. And I have a dashed line for this one as well. So I draw a dashed line here. From here, now I have to determine the shading. It's got to be shaded underneath this one. So I'm going to put an X here. So it has to be shaded underneath that line, but it also has to be shaded underneath the other line, underneath here. So wherever I see both X's, that's the part that I want to shade in. So this is where the solution would be. Another way to determine this is use a test point. So choose a point. Normally I would say choose 0, 0, but since point 0, 0 is on one of the lines, I don't want to use that. So if I chose, let's choose 1, 0. If I choose X is 1 and Y is 0, if I put those in, it should be true. So this would be, here would have Y is 0 when 0 is less than 3 times 1. 0 is less than 3, so I know that's true here. If I put a 0 here and a 1 here, 1 minus 0 is 1. 1 is greater than -6, so I know that is the side that I need to shade on. Here is another way. This is the same problem here, just showing you where the shading would be. So we graphed it. You can see on both of our lines, we have shading underneath the top, this top line here. Then we got shading underneath that line. And where the overlap is in this section right here. So the solution would be everything in the green area. Now theirs just looks a little bit different just because the size of the coordinate plane, but it's still the same section that we shaded in. Going on to the next example. Solve this system. Here I have x is less than or equal to 2. So I go to the x-axis and put a point at positive 2. And it has to cross that. So it's a vertical line and it's a solid line. And it says that it's greater or less than that. So that means I have to shade to the left of that line. I'm going to do the shading at the very end. Next one, y is greater than 2/3 x minus 1. So I put a point at -1 and I go up 2 to the right 3. This one doesn't equal it, so I have a dashed line. And this one has to be above the blue, so above the blue to the left of the green. And the only one that has that would be this part here. So above blue, left of green, any point in the yellow shaded area would be a solution. Next one, graph this system. Here I read it as y is greater than 1/3 x plus 2. So I put a point at 2 on the y-axis, slope of 1/3, so up 1 to the right 3, or I can go down 1 to the left 3. It doesn't have the equal to sign, so this is a dashed line. And the other one, x is greater than or equal to -3. So I go to -3 on the x-axis. It's a vertical line. It crosses a solid line because it can equal that. So there's our graph. And then we need to shade. So y has to be greater than the red. So above the red and to the right of the green. So that would be everything over here. Next example, solve this system here. So here I'm going to make both of them into y equals mx plus b. This first one, if I rewrite this, I got add 3x and then divide by 4. So it'd be y is greater than 3/4 x plus 0. And I'm not going to put the plus 0 in there. And then the other one, I need to subtract 3x and then divide by -4, which means I do have to flip the symbol. So now it'd be less than or equal to be a negative 3x divided by -4, which would be a positive 3/4 x. And then 8 divided by -4 is a -2. Now, if I were to draw the line here, so for the top one, put a point at 0, 0. Slope of 3/4, so up 3, 1, 2, 3. To the right 4, 1, 2, 3, 4. Or I can go down 3, 1, 2, 3. To the left 4, 1, 2, 3, 4. It's got a dashed line, so I'll put a dashed line through here. And then the other one, we have point at -2, has a slope of 3/4. So if I go up 3, 1, 2, 3, to the right 4, 1, 2, 3, 4. Or I can go down 3, 1, 2, 3, to the right 4, left 4, 1, 2, 3, 4. This one has a solid line because it can equal it. If I draw a line through here, you can see that they don't cross because the slope is the same. Now the shading part. It has to be above the green and below the blue. So above the green means here, and below the blue is down here. So there is no overlapping because where it is, so they don't share any solutions. So the shading is on the top and on the bottom of our two lines. Next, solve this system. Top one here. If I rewrite this as y is greater than or equal to 2x plus 1, and this one here, I need to subtract 2x and then divide by -1. So that means I have to flip the symbol, and I would have positive 2x and then -4. So now if I graph these, I'm going to graph this top one as blue. So I would have a point at 1, slope of 2, so up 2 over 1, up 2 over 1, or down 2 over 1. This one has equal to sign, so it does have a solid line. Then I'll use green for this other one. Put a point at -4. Has a slope of 2 as well, so up 2 over 1, up 2 over 1, or down 2 to the left 1. This also has the equal to sign, so this is a solid line. Lines are parallel. Now the shading. For the blue one, it has to be above the blue and below the green. So there's nothing that's overlapping. So nothing shares solution with the two inequalities. Next, graph this one. So here I have y is greater than x plus 3, and this one, the y, I need to subtract 3x and then divide by -3, which I need to flip the symbol, which would be less than or equal to be just 1x, and then 12 divided by -3 would be a -4. So again, these are going to be parallel lines. I'm going to use the top one is blue. And I'll put a point at 3, slope of 1, so up 1 over 1. Doesn't equal it, so it's a dashed line. The other one I'll use red for, put a point at -4, slope of 1 as well. Does equal it, so I have a solid line. The shading, it has to be above the blue and below the red. So again, there's no overlapping, therefore there is no solution to that. And example 3, applying them with a word problem. It says a family and consumer sciences class is making pillows and blankets to donate to a local shelter. The class has 40 yards of fabric to use. Pillows require 1.25 yards of fabric and take 1 hour to make. Blankets use 4 yards of fabric and take 2.5 hours to make. The class has 28 hours of class time left for the semester. Determine the number of pillows and blankets the class can make for the shelter. Use a graphing calculator to solve. So the first thing we need to do is come up with our system of equations. So to write our inequalities, or our system of inequalities, one of them is going to deal with yards. So I know, and I'm going to use x for the pillows and y for the blankets. So if I have 1.25 yards per pillow plus 4y for the blankets, this has to be, you have 40 yards, so I can use less than or equal to 40 yards, so I can't use more than 40 yards. That would be one system. The other one will be dealing with the time it takes. And it says they have 28 hours to use, so this is going to be less than or equal to 28. And it says for pillows, 1 hour to make, so that's 1x plus 2.5 hours to make a blanket, so 2.5y is less than or equal to 28. So now that we have our two equations, I need to rewrite them so I have them in y equals mx plus b format. So the first one I'm going to do is I need to subtract 1.25 on both sides and then divide by 4. So that would be negative 1.25 divided by 4 would give us y is less than or equal to a negative 5/16 x, and then 40 divided by 4 would be a positive 10. And this other one, I would subtract 1x on both sides and then divide by 2.5. So negative 1 divided by 2.5 would give us y is less than or equal to a negative 2/5 x plus 28 divided by 2.5 would give us 11.2. So those are our two equations that we're going to use to graph. So I'll grab my calculator and then we'll show you how to graph it on your graphing calculator. First thing we're going to do is clear everything in a y equals. And the first one I'm going to put in, I'm going to do in parentheses negative 5 divided by 16, x plus 10. And then the other one, we're going to do negative 2/5 x plus 11.2. Now here I need to determine where I'm going to shade it. So if I go over here to the far left, the first one, it has to be below. So when I hit enter, it changes that line. And underneath means I need a lower left corner shade. So that means less than. Now if I go down, the other one is also less than. So I need to keep hitting enter until I see that bottom triangle. Now that we have that, I'm only really worried about quadrant 1 because I can only use positive numbers. If I go to my windows, I'm going to change the x minimum to 0. The maximum, we'll make that 50, and then we'll just count by tens. The y minimum is 0. We'll make the y maximum also 50, and we will count those also by tens. So let's see if we can see that on our graphs. If I hit graph, here's the first one. Here's the second one. And you can see the overlapping parts. But let's go back to let's change this a little bit so we can see a little bit better. The x maximum, let's just go 20. And we'll count by fives. The max, let's do this by 20 and count this by fives as well. Let's see if that makes a difference. So here's that first equation. Second one, you can see there, overlaps a little bit here. Now let's look at the solution here. So here's what ours look like. You can see that a little bit better with the different colors of shading here. We have our two inequalities, and we have to find a viable solution, which means what would be a possible solution we could have. Anything in the green area is the solution. So if I did 4 blankets, I could have 4 blankets and 12 pillows. I could do 2 blankets and 18 pillows. I can choose any of those points as long as it's a whole pillow and a whole blanket. You can choose any of those points that fit in the green line or the green shaded area. Next, Jesse is planning a fenced area where his new puppy. He wants the perimeter of the fenced rectangular area to be at least 60 feet. Because of the size of his yard, the width of the area must be less than 25 feet. To determine viable solution possibilities for the dimensions of the fenced area, find 3 viable solutions. So let's come up with our 2 equations. We're going to use the length as our x and our width as our y. So if I do length plus width, that has to equal, or 2 times the length plus 2 times the width will give us the perimeter. So if I use these variables, so I'm going to have 2x plus 2y equals the perimeter, and the perimeter says it has to be at least 60. So that means greater than or equal to 60, no less than 60. The other one, it says the width, and our width is going to be w. The width has to be must be less than 25. So less than 25. So those are our 2 inequalities we're going to have here. I'm going to rewrite this one so I can graph that one. That means I subtract 2x and then divide by 2 on both sides. So that would be y is greater than or equal to negative x plus 30. So on my calculator, come over here. My y equals, going to clear everything that I have here. First one would be negative x plus 30, and it has to be above that line. Shading has to be above that one. So I'm going to hit enter until I see the shading at the upper corner. The next one is going to be 25, and the shading has to be less than that, so the lower triangle. I'm going to change my window settings so I know that the x is my length. I'm going to choose, I'll keep it at 20, and then the y maximum has to be less than, width has to be less than 25. So I'm going to make this 30. Make sure that we can see it. Now if we hit graph, there's one equation. Here's the other equation. Now what I need to do is find a point inside the dark shaded area. Now if I want to find out where these lines meet, like here, again I can just hit second, trace, intersection, 5, hit enter 3 times, says 5. So this is 5. So it has to be, the x has to be more than 5, and the y has to be 25, less than 25. So we know anything over here is more than 5. And then it has to be less than 25 here. So let's just say, go to our table. We can't have negative numbers, so we're just getting rid of those negative numbers. The x has to be more than 5, and it has to be less than 25. So I could do 6 and 24. That could be a possibility. I could do 7 and 23. Let's do one for sure. Let's do 10 and 20, because 10 and 20 would work in there. So I just need to have three possibilities. So 10 and 20 would be a viable solution. I could do, we go back to our calculator. We could do 11 and 19. And we could also go 9 and 21. All of those would be viable solutions for the fenced-in area. Now to check it to make sure that it does make sense, if I plug those in for x and y, so 2 times 10 is 20, 2 times 20 is 40, 20 plus 40 is 60, so that's the bare minimum we could have because it has to be greater than or equal to 60. If I did 11 and 19, 2 times 11 is 22, 22 plus 2 times 19, that would be 38 plus 22 gives us 60. We could do 3 times 9, which is 18, plus 42 gives us 60. So these are just the bare minimums that you could have. If we did another one, let's just say we did 12. 12 would be matched up with 18. So that's 24 plus 36, also 60. So that would be some possibilities with that in there. Moving on. Aisha can work 20 hours per week working at a bakery. She earns $7 per hour most of the time and $8.50 per hour during the early morning shift. Aisha needs at least $150 this week to pay for a trip with her friends. Determine the number of regular and early morning hours that Aisha could work. So let's look at our choices here. So part A, select the correct system and graph. Let R equal the regular hours and M the early morning hours. So the total amount of hours at minimum or at maximum is 20 hours a week. So at most 20 hours. So it cannot be more than 20 hours. That means your regular and your morning hours, that eliminates A because that just tells us the regular is less than 20. That eliminates this one here because that one has 7R plus 8.5R and greater than 20. So it's between B you get $7 an hour for regular and $8.50 for the morning. So you got to get at least 150. So the correct one would be actually C here. Part B, identify each solution as a viable or non-viable. So if we go back and plot those down, 217, 217 would be roughly here. That is not in there, so we would say no for that one. 4, 7, 4 and 7. So 4 and then 7 would be here. So that would be yes. That's viable. 5, 15. 5 and then 15 would be in here. So no, that is not. Actually, the one that we would have to use has to be less than 20. So that would be less than the top line, but more than the other one. So we're looking actually at the green one. We're looking at the green shaded area. So if I go back to this one does go in, this one does not. 515 is in the green, so that is yes. 813, 813 would be above here. So no, that is not one. 1010. So 1010 would be inside the green. So that would be yes. 18.6. 18.6 would be up here, so no. And then the last one, 21.6, be past here, up there, so that would be a no as well. So these last two are no. So that is our lesson on systems of inequalities.